Hey guys, today we're going to talk about the scientific method and how do scientists solve problems. Well, they use steps that are often called the scientific method. They ask questions, they do research, they make and carry out a plan, they collect and record data, they analyze that data, they make conclusions, and they share their results. Let's go ahead and look at that a little bit further. First, they start by asking questions about the natural world. The natural world is everything on Earth or in the universe that we know of. So they can be asking questions about clouds or rockets or people or flowers or dogs. Any of those things are part of the natural world. It's part of what scientists ask questions about. We call this their purpose, what they want to learn or solve. So when we're doing an experiment and I say, what's your purpose? What are you questioning? What are you trying to find the answer to? What are you trying to solve or learn? Then they do some research. Okay, so if you lost your shoes, do you go out and buy new shoes before you even look? No, you go, you look, and if you can't find it, what do? You ask around and you say, hey Mom, have you seen my shoes? I can't find them. I don't really want to make a pair out of duct tape. Have you seen them? Do you know where they might be? So you do research when you lose things in your house. Scientists do the same things when they're trying to Scientists do the same things when they're trying to ask those questions and when they're trying to solve that purpose. They use books. They might ask another scientist or a friend or someone else. They might do some research on the internet. All ways to do research. Is there already an answer out there? And what do we already know? So someone else may not have done the same exact thing. They may not have answered that exact question, but they may have answered something similar that gives you an idea about what the answer might be, or at least gives you some tools to figure out how you might test that question. And that's the next plan, coming up with a solution that they think will work, what they think is going to happen. And we call this the hypothesis. Your hypothesis is a predicted outcome, what you think is going to happen. Hypothesis is your predicted outcome. And scientists say it in an if-then statement. If I do this, then this will happen. In a hypothesis, scientists don't say I think. They don't go, well, I think if I do this, then maybe this might happen. It's a hypothesis. We know it's a prediction. We know it's an educated guess. We know you've done your research, you've made this plan, you have this idea of what might happen. You don't have to say if and then. You don't have to say if and maybe. So if I do this, then this will happen. Done. That is what you think will happen. Sorry guys, this is the trickiest part of these things, is getting the boards to slide. Alright, so your next step is you're going to make a plan. You've done your research, you have a question, you've done your research, you've come up with an idea that you think might work. Now you're going to make a plan. This plan is going to be step by step. It's not going to say, put some peanut butter on your sandwich. It's going to say, get a knife, open up the jar, put this much specific amount of peanut butter on your bread and smear about generously. Step by step, it's very specific. It's so easy that other people can follow it. They don't have to say, hey, what is this? I don't understand what to do next. So if you're ever making your plan, you need to make sure that it is step by step and anyone can use it. It's what scientists use to test their hypothesis. And we're going to talk some more about exactly what a procedure should have. But your plan is also called a procedure. This is a step-by-step plan for your investigation or experiment. Then you're going to carry out the plan. Okay? So I had a question, did some research, I figured out what I think might solve it, I made a plan. Now, well, duh, of course I'm going to carry out the plan. But I'm not going to make things up as I go along. I'm going to go by that procedure point by point by point. Now, if I realize I missed something, I have to add that into my procedure. You're doing exactly what you told us you were going to do. And as you're doing that, you're collecting your data. This is happening during your experiment. You're collecting data. Data just means bits of information. So you might be recording how tall something is. You might be recording how long something is. You might be recording how heavy something is. That's all data. Little pieces of information about what's happening in the experiment. It's what you observe while you're testing your hypothesis. And remember, when you're collecting your data, that scientists use metric units. They use meters, grams, liters, newtons. No feet or inches here. So collecting your data is just your notes and your measurement. This is happening during your experiment, during your procedure. We're getting right to the end. Our next step is analyzing the data. So you did your experiment, you took data, you measured, you observed, you wrote all of that down. Now you're looking at these pieces of information and seeing what happened. This happens after experimenting. You're looking at what you observed and measured and recorded. Do your notes make sense? Did what happened make sense to you? Do you have something that, okay, it's going, and then all of a sudden it gets taller and then shorter again? Maybe something happened there while you were experimenting. Maybe your little sister knocked over and then taped it back together the next day. You have to think about those things as you're analyzing your data. Does this make sense? Is there a pattern? Can you say, yes, my hypothesis is correct, or no, my hypothesis isn't? Are you quite sure what happened, or is your data all over the place? Did this plant get taller, and this plant get shorter, and this plant die, and that plant go, I don't know, in the trash because somebody knocked it over? Is there a pattern? Do you see your data answering your question? And a lot of scientists at this point make a graph. They take that data, they make a picture with it, and then they can go, oh look, that one's the tallest. That must be the hottest time of day. I wonder why noon would be the hottest time of day. Let me look at my observations. Oh yeah, I always noticed the sun was really bright out then. So whenever you're analyzing your data, you're looking at what you observed, what you measured, and you're trying to see if you can find some patterns that make sense that help you answer your question. And finally, your conclusion. Is your hypothesis correct or invalid? Did you say, if, then, did that happen? If this happens, then this will happen. Is that exactly what happened in your experiment? Did something that you didn't expect happen? It's okay if your hypothesis is not correct at the end. That's fine. All you have to tell us is what the data shows. When I did this, this happened. So it's okay if your hypothesis was incorrect to begin with. That's totally fine. Why do you think that happened? What could you do differently if you did the experiment again? Or what do you want to know now that you've done the experiment? And then finally, you share your results. Just like when we were doing research, we wanted to see, did somebody else already do this? Did they already find something out about this? Someone else might want to know what you found. So tell a friend. You can put it online. Or you can save it for our science fair. So those are the steps of the scientific method and how scientists solve problems. And we'll talk again soon. Have a great day.